This video is going to cover the NetIonic equation notes. So we are on page 10. You want to have your periodic table. You also want to have your polyatomic ion list, and you may want to have a different color for balancing. So we are going to look at what happens when we mix two aqueous solutions, all right? So when it comes to aqueous solutions, right, they contain ions, right, and they are mixed, and those ions may react in a double replacement reaction. The product is typically a solid, right? So we know that that's a solid, precipitate, or it can be water, which is a liquid, or a gas. But now that we know how to determine which substances are going to form solids, we can actually figure out which one is the solid in the solution mixture here, okay? So if I add NaCl aqueous and AgNO3 aqueous, I have these types of particles in solution. I have Na plus, right? And I also have Cl minus in solution. So that would be the NaCl, right? And I mean, I'd have multiple ones, right? So I'm just going to go ahead and show that I have two of the ionic compounds separating. I also have AgNO3 separating, so I have Ag plus and the NO3 1 minus, Ag 1 plus, and the NO3 1 minus. But it's not that simple to just say that those two things are reacting. In fact, I'm going to show you that experiment here, all right? So I have here just a acetate sheet, which is just a plastic sheet, right? And I'm going to add these chemicals. So I'm going to add my NaCl, so that's aqueous. And so I'm going to add my NaCl, so that's aqueous NaCl, just salt water. And then I'm going to add my AgNO3 there, and you can see that there's a precipitate that formed. It's a white precipitate. Well, what is that white precipitate? Okay, so when we do our double replacement reaction, I have Na plus, Cl 1 minus, Ag 1 plus, NO3 1 minus, and remember, these two switch places. And so I end up with the Ag 1 plus, Cl 1 minus, and the Na plus, and the NO3 1 minus. And that's how I get these up here. I don't have them in the same order as if I were to switch those, so I kind of had to write them in opposite order. But the point is that now I can tell what this solid is. So I look at my solubility table, and I look at the nitrate. Here's my nitrate. It's soluble, so that is aqueous. So Na plus and NO3 minus are just hanging out in the actual beaker, whatever container I have. Now let's look at AgCl. Here's a Cl minus, soluble. So remember, soluble means it's most likely going to be aqueous, except Ag1 plus. Well, we have Ag1 plus. So that is my solid, all right? So what does that mean? It means that these two come together. And what they do is they're the ones that are forming the solid at the bottom. And that's important because now I know what this white precipitate is. It's silver chloride. So we can be more specific about two types of reactions and talk about spectator ions. The complete ionic equation is an ionic equation that shows all of the particles as they really exist. So it's either going to be an ion or a solid. So that's going to be either ions or a solid. It could technically also be liquid water. All right. So here, ion, 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 when I first mix them together. And then these two are the ions that did not participate in the reaction. And then the solid stays together. So that would be the one that stays together. Now, spectator ions are the ions that are present but don't react. They don't react in the reaction. Guaranteed to be on the test, you need to know what spectator ions are. So in this case, which ones did not form the solid? Na plus and NO3 minus. So those are my spectator ions. Na plus, aqueous, and NO3, 1 minus. The net ionic equation is the net reaction. It's what is the product that I'm focusing on. It's the ionic equation including only the particles that participate in the reaction. So the ones that make solid or liquid H2O. So in this example, remember AgCl was my solid that stays together. So I want to include the Ag1 plus and Cl minus. So we're going to recap again. This is a double replacement reaction. I figure out the products. We learned that when we did predicting products of double replacement reaction. But now what we can do is figure out which ones make up the solid. How do I know what makes up the solid? I have to look at the solubility chart to see which one makes it turn into a solid. You have to write the complete ionic equation. That means you write everything as an ion unless it makes the solid or the liquid water. You only keep it together if it's a solid or liquid water. Spectator ions are the ones that don't react. Essentially, those are the ones that we kind of lightly cross out because they did not participate in the reaction. The net ionic is only looking at either the solid or the liquid water and showing which ions make up that solid or liquid water. So now we're going to put it all together and we're going to finish on page 11. So how am I going to systematically know how to find the complete ionic and net ionic equation? The first thing you're going to do is predict the products of the double replacement reaction. Second thing is you're going to balance. The third thing is you're going to find the states of matter. If it's insoluble, we know that it's a solid. Soluble is aqueous, and if it's H2O, it's a liquid. We have yet to see this type of example, but you need to know how to do it. If it's H2O, it's going to be a liquid. Okay, don't make it aqueous. Then we write the net ionic equation by canceling out the spectator ions, and we haven't talked about this, but double replacement can be a no reaction. But it's not because you're looking at a activity series, okay? So now we're going to look at the first example. Before I put this away, I kind of folded the the reaction over so you can kind of see, but you can definitely see that silver chloride has formed, and I have that solid precipitate. If I really wanted to, I could filter out that silver chloride by using a filtration apparatus. Okay. All right. So here's an example. If I have lead 2 nitrate with sulfuric acid, I first figure out the ions, figure out the products, and then I balance, then I figure out the states of matter, then I write the net ionic by canceling out all the spectator ions. So we're going to do this example together. These problems require attention to detail. So the first thing I'm going to do is separate these into ions. The nice thing is you have your ion list and you have your periodic table. Okay? So there should be no guessing on what the charges are. So I have zinc. Zinc is 2+. So I write Zn 2+. NO3 is nitrate. NO3 1-. All right? And there's a 2 here, and I'm just going to highlight that so that I can see how that's going to affect my reaction. So I'm going to highlight that and see how that affects my reaction. Not yet, but that's important because it's not a part of the ion. Then I have the ions that make up BaOH2. So I separate those, right? Ba is 2+, and OH is hydroxide, OH 1-. All right, once again, I have a 2 here that did not pertain to the polyatomics, so that's going to play an important role in a little bit. Now, first thing is predict the products. So I'm going to go ahead and have these switch places. So I have Ba 2+ with NO3 1- and Zn 2+ and OH 1-. I go ahead and reduce crisscross. So this is Ba NO3 2 plus Zn is 2+, OH is 1-, so Zn OH 2 capital letters. So if I cross a 2, I need parentheses. So I did step 1. I predicted the products of the double replacement reaction. Step 2, I balance. All right. To balance, right? I have 2 OHs here, 2 OHs here. 1 Zn here, 1 Zn here. 1 Ba, 1 Ba. 2 nitrates, 2 nitrates. It's already balanced, but you can't forget to balance. Now I'm going to go to step 3. Figure out the states of matter of the substances on the right. So I'm going to look at the solubility chart, and we're going to look at nitrates. Nitrates are all soluble. So this now is aqueous. Now I do the same thing for zinc hydroxide. So I look for hydroxide insoluble except group 1A. Group 1A would be all of these. Zinc is not there. Ca2+, zinc is not Ca2+, it's not Ba, it's not Sr2+, it's not NH4+. So it's insoluble. So this is my solid. Okay? Now, what I like to do is I like to circle the solid once I know which one it is, if it is one. So I circle that and I keep it circled. All right. Now what I have to do is do the complete ionic equation. If you have already written these ions out, it's going to make it so much easier to write the complete ionic equation. So I start with zinc, right? 2 plus. So now the complete ionic is to write them all as ions, except for the solid you keep together, or liquid water you keep together. So I have Zn 2 plus. That's aqueous, so I put AQ plus NO3, 1 minus, aqueous. Remember how we had that 2 there? That 2, though, has to go here. Any questions on that? Then, next one, Ba 2 plus. That's aqueous. Plus OH, 1 minus, aqueous. Remember, there was a 2 there. That goes there. Now, I have to write this one as ions because they did not participate in making the solid. So I have Ba 2 plus. And I want you to recognize something. There's a 2 here. And that's going to be important because I'm going to need that for when I do my complete ionic equation. So this is AQ still, plus my nitrate is NO3, 1 minus, aqueous. So if you get confused, right, here's nitrate. That has to look like this here. The only way I can account for that 2 is by putting it as a coefficient. I can't have a 2 after it, right? So for example, there's no NO3, 1 minus 2. There's nothing like that on here. So your ions should look clean. They should look like this. The only way you can account for multiple ions is by putting a coefficient in front for the complete ionic equation. Okay? And then remember, we keep the solid together. That stays together. So that's going to be my ZnOH2 solid. All right. Now, something I like students to do first is to count how many states of matter they have. 1, 2, 3, 4, 5, 6, 7. You should have 7. You should have 7 states of matter when you're doing the complete ionic equation. You have 7 states of matter. The next thing you should do is make sure that you have the same number of ions on both sides, all right, that are not participating in the making of the precipitate. So let's see how that works out. Ba. Do we agree that we have 1 and 1? Yes. Those cancel. I'm okay with you lightly canceling these. Don't completely cross them out, okay? So that I can't see them. Nitrate is not a part of the precipitate, so I'm going to go ahead and cancel those. Another thing you want to pay attention to is I have 2 here. I need to have 2 over here. Let's say I have 2 here and 1 here, then I probably didn't distribute or I didn't balance correctly. So that's another way to check your work. All right. Now, we have our zinc hydroxide. That's my solid. The rest of the ions now are going to be written so that they make the solid. So now I have my Zn 2 plus aqueous plus the 2 OH 1 minus aqueous, and that's going to give me ZnOH2 solid. And that is my net ionic equation. Remember, the solid stays together. If you want to circle that, you can. All right. So now we're going to move on to the next one. CuOH2 and H2SO4. We're going to predict the products of the double replacement reaction. When we learned double replacement, we learned that we had to write out the ions so we can see how the positive ions are going to switch places. So here, Cu, remember Cu can be 1 plus or 2 plus. So I got to see what OH is. OH is 1 minus, and I need 2 of those, right? So this has to be 2 plus. I'm going to highlight this too because that's going to be important when I do my complete ionic equation. This is sulfuric acid. That's why it's aqueous, but I have to still separate it into the ions. So remember, sulfuric acid comes from sulfate, so that's SO4 2 minus. This is H plus, but that 2 is going to be important when I have to look at my complete ionic equation. So now, to figure out my products, I'm going to switch the positive ions. So I'm going to have H plus and OH 1 minus and Cu 2 plus and SO4 2 minus. I'm going to reduce crisscross. H plus and OH minus gives me HOH. And what I want you to know is that H with H plus and OH minus is H2O. And you want to keep that as a liquid. Cu2 plus and SO4 2 minus is going to be CuSO4. All right. So now I have figured out what is the product that I'm looking for. It's definitely the liquid water. Remember, we're either going to keep together the liquid water or the solid. I made water here. That's what I care about. So now I have to balance. So to balance this, right, I'm looking up here. Here's Cu, same amount. SO4, same amount. But there's 2 OHs and 2 H's. So to balance this, I'm going to put a 2 in front of H2O. So now I'm going to move on to step 3. Step 3 says find the states. Insoluble, put solid, soluble aqueous, H2O liquid. My H2O was already liquid. I know that. So I got to look at what CuSO4 is. SO4 is over here. It's soluble. Here are some exceptions. None of those are Cu. Soluble means that this is aqueous. I kind of already knew that that was aqueous because this is what I'm forming. You're not going to have a liquid and solid at the same time. So now I'm going to do my complete ionic equation. Remember, I have to keep either the precipitate solid, which we don't have in this one, or the liquid water together. So I'm going to keep that H2O here. That is the product that I'm focusing on. And there's a 2 in front. Okay? So now I'm going to write the complete ionic equation. So I start here. I have Cu 2 plus aqueous plus, remember that 2? So now I have to account for that 2. 2 OH 1 minus aqueous plus, here I have H plus and SO4 2 minus. Remember that 2? This is where it's important because now that 2 is going to go here. These are aqueous. These are going to form the 2H2O liquid, and these did not make up a precipitate or the liquid water, so these stay as ions. Cu2 plus aqueous plus SO4 2 minus aqueous. All right, let me double check that I have 7 states of matter. 1, 2, 3, 4, 5, 6, 7. 7 states of matter, so that's going to help me. Another thing I could do is see if I have the same amount of ions on both sides. So first I look at the ones that didn't make the H2O. Cu didn't make up the H2O, so do I have equal amounts? Yes, Cu2 plus on both sides. The SO4 2 minus didn't make up the H2O, equal amounts. So now I'm left with what made up the H2O. Remember, I always keep the precipitate or the liquid water together, so I'm just going to go ahead and keep that together. 2 H2O liquid. All right. Now I have left over the 2 OH minus and the 2H plus. A general rule is to put the positive ion first. So I'm going to put the 2H plus aqueous plus the 2OH 1 minus aqueous. If you put the negative ion first, I'm not going to mark you off, but it's just something that you want to get into a habit of. We try to put the positive ion first, just like how we do with ionic compounds. But I want you to notice something, right? 2, 2, 2 is not in lowest terms, and this can happen with water. So you have to remember to reduce. So this is 1, 1, 1. So I'm going to tell you right away that this is a no reaction. But I want you to know how to do it, okay? So first thing is I predict products, so I'm going to write the ions. Cu and Cl. Cl is 1 minus. Remember, that 2 is going to be important. That 2 is going to be important because it's not a part of the ion, but it's a part of making it, right, cancel to make an overall charge of 0. So the charge on Cu can be 1 plus or 2 plus. It has to be 2 plus because I need 2 Cls. Separate these ions. Na plus, NO3, 1 minus. Right? So now positive ions are going to switch places. Na plus with Cl 1 minus and Cu 2 plus and NO3 1 minus. I'm going to reduce crisscross. This is NaCl. Cu2 plus and NO3 1 minus is Cu NO3. Okay, so I have predicted my products. Next thing I do is I balance. So 2 nitrates here, only 1 here. So I'm going to go ahead and balance that. So I'm going to have a 2 here. There's 2 NAs now, so I'm going to put a 2 here. Cus are okay. Cl's are good. So now I'm balanced. So remember, we've done step 1, step 2, step 3 is find the states. All right. NaCl. I know that NaCl is table salt. I know that table salt dissolves in water. But I'm just going to double check on my solubility table. Cl minus is soluble. Except these 3, non-exception, so this is aqueous. CuNO3 too. NO3. Soluble. No exception. So this is also aqueous. So what does that mean? That means, right, that there's no precipitate forming. What if I have, right, my NaCl? So I'm going to go ahead and drop my NaCl. And now I'm going to drop my CuNO3 too. And I want you to notice that it still looks clear. But the reality is that I have all these ions free floating in solution. And I want to make sure that I represent that. So that's what we're going to do now. Okay. So there's nothing to circle because I didn't form a solid. I didn't form water. I'm going to rewrite the complete ionic equation. So I have Cu 2 plus aqueous plus Cl 1 minus aqueous. All right. Remember that 2? This 2 here now has to be accounted for here. Plus, I need to distribute this 2 into here and here, which means I have to distribute that to these ions here. So that's going to be 2 Na plus aqueous plus 2 here, NO3 1 minus aqueous. Nothing stays together. So now, once again, these have to be distributed to Na plus aqueous plus 2 Cl 1 minus aqueous plus, now I have to write these, right? There's nothing to distribute here, so Cu 2 plus aqueous plus, I got to be careful with this 2 though. That 2 is going to be accounted for here. All right. Now, what if I would have forgotten this 2 here? Do you see how there's a 2 over here? Right? I wouldn't notice because it wouldn't cancel out. Now, for a no reaction, when you do your complete ionic equation, you should have 1, 2, 3, 4, 5, 6, 7, 8. 8 states of matter because nothing cancels. Nothing is forming a precipitate. So in the net ionic, it's not going to give us a net product. It's not giving us a net precipitate or liquid water. So this results in a no reaction. But I could double check that I have the same amounts on both sides. This is the same as this, right? This is the same as this one. This one is the same as this one. This one is the same as this one. Okay? So I just use different notation so that I know that I had equal amounts. So this is a no reaction, but I still have to show the left side. So all I have to do now is rewrite this here. So I have Cu2 plus aqueous plus 2 Cl1 minus aqueous plus 2 Na plus aqueous plus 2 NO3 1 minus aqueous. All right. So now, we are officially done with notes. I want to talk about the homework. For the homework, you're going to do 2, 3, 4. And show what happens down here. So we're going to do this first one together. All right? So we're going to look at separating lead to acetate and ammonium chloride. So we're going to do the first one together. We're going to separate the ions. So I have my ion list because I can recognize that that's acetate. So that is acetate, C2H3O2. So I have C2H3O2, 1 minus. Okay, that 2 is going to be important. So if it's PbC2H3O2, the Pb can be 2 plus or 4 plus. It's going to be 2 plus. Now these separate into NH4. I know that that's ammonium, which is right here, NH4, 1 plus. And Cl is 1 minus. So now these two are going to switch places. So over here, I have NH4, 1 plus with the acetate now, plus Pb 2 plus and Cl 1 minus. So now I'm going to go ahead and reduce crisscross. So this is going to be NH4 C2H3O2 plus PbCl, cross those, 2. Next thing I do is I balance. I can see that I have 2 acetates here, right? So I'm going to put a 2 here. Now I have 2 ammoniums, so I'm going to put a 2 here. And the PBs are balanced, and now the CLs are balanced. So I did step 1, step 2, step 3 now is predict what are the states of matter for the products. So here's acetate. Acetate is right here. All of them are soluble, no exceptions. So this is my aqueous product, and PbCl2 is chloride. So I'm going to look for Cl1 minus, soluble. Oh, here's Pb2 plus, which is an exception. So usually it's going to be aqueous, but this is an exception. So that is now a solid. So of these two, I want to keep this together. Now I'm going to do my complete ionic equation. So I write Pb2 plus aqueous plus C2H3O2 1 minus aqueous, and then I have this 2 here. So that 2 is going to go here in front of acetate. Plus, there's a 2 here. I have to distribute to both of those ions. So that means it's going to go to the ammonium and the chloride. So I'm going to have 2 NH4 plus aqueous plus 2 chlorides. And then that's going to give me, right? Once again, I have to distribute this 2, NH4 1 plus aqueous plus 2 C2H3O2 1 minus aqueous plus what I have to keep all together, which is my precipitate solid PbCl2 solid. All right, so now do I have 7 states of matter? 1, 2, 3, 4, 5, 6, 7. Yes. 7, yes. Do I have the same amount of ions that did not make up the precipitate or the liquid water on both sides? Well, let's see. Pb makes up the Cl2, so I don't want to cancel that out, but this one doesn't. So I'm going to gently cross that out. Ammonium is not a part of this, so that also cancels out. There's 2 here, 2 here. 2 of the acetates, 2 of the acetates. So now I'm left with my ions that make up my solid. So remember, the ones that cross out, those are my spectator ions. They don't participate in the making of the liquid water or the solid precipitate. So here I have PbCl2, solid. And then what makes up this solid would be the Pb2 plus aqueous. Remember, we want to put the positive ion first, and then 2 Cl1 minus aqueous. And this should balance too, right? So this here has 2 Cl's, 2 Cl's. Okay? So now you'll have to do 2, 3, and 4. But we're going to look at what this means down here. Down here, right, for every 1 Pb, this is problem number 1, right? This is Pb2 plus, and there's only one of them, and there's 2 acetates. There's NH4 plus and Cl1 minus. So notice, right, how I drew them in here. That's all I did. And then what I said, right, is the ones that made up the solid, PbCl2, that's what I made the solid here. Okay? On the first day of net ionic equations, students tend to make a couple of mistakes. So these here are worth 1 point extra credit each towards this assignment. So this here you don't have to do, but I don't think it's too hard, and you're already figuring it out for these problems. So I would take the time to do these 3. All right? So make sure you have these, and then go ahead and upload it or have it in class for when you need it, depending on what it says in Google Classroom.